Accidents and disasters happen, but always for a reason. They are not random events. Investigations afterwards often reveal that the causes were known before the incident occurred. The idea of risk management and formal safety assessment is to identify, assess, and manage the risks before they lead to an incident. The aim of this video is to show how the ship's management team can begin to manage the risks on their own ship. There are underlying causes for every event. To take an example, the destruction of the Challenger space shuttle.
7, 6, we have main engine start. 4, 3.
The cause of the explosion was traced to the failure of the O-rings which held together sections of the external fuel tanks. But it was not just a simple technical failure. The Presidential Commission investigating the accident discovered that the possibility of O-ring failure under the cold weather conditions of the launch was well known to the engineers who designed and made them.
Challenger, go with throttle up.
But they were unable to convince their managers to halt the flight. Those in direct charge of the launch were never informed. The launch went ahead with tragic results. The equipment did fail, but the essential failure lay elsewhere. Wherever there are choices, there are risks.
You can see as we get out between the San Carlos breakwaters that there's a continual...
From the boardroom to the bridge to the engine control room, good managers have always known that. They keep their operations effective by being aware of the hazards around them and making sure that they avoid them. Much of the time, this is done unconsciously, even intuitively. Risk management seeks to bring this process out into the open and make it a central feature of each and every procedure. This benefits everyone on the ship.
A seafarer needs to know about risk management because a seafarer in his day-to-day work is exposed to a lot of hazards, a lot of risks he has to take when he's doing his job. Therefore, if he has safety on his mind as the highest priority, then he can know when to take a risk and when not to take a risk.
The risk associated with any operation is a product of two factors: the probability of the hazards materializing and the consequences if they do. The probability of an incident from any given hazard will vary from low through to high. The consequence can be small to large, even catastrophic. So an unlikely event with little or no impact has a low risk. Perhaps nothing needs to be done. But in any other area on this diagram, risk management should be considered to reduce the risk. This may mean both reducing the probability and minimizing the consequence. Risk assessment is also dynamic. If any circumstances change, the risk will always change too. You cannot avoid risk, so the objective must be to manage it. In the case of the Challenger, although the chance of the hazard occurring was thought to be very rare, the consequences would always have been catastrophic.
The explosion appeared to come from one of the solid rocket boosters which supply most of the power for the liftoff.
When you're approaching the dry dock, okay, let's pull out the chart.
The risk management of any operation needs to take a very wide view of the potential hazards.
When you're approaching the dry dock,
Although these are often apparent, the assessment of the risk they represent may be subjective. Statistics are not always available. Different people will have different views on how often the hazard might happen and how bad the result might be.
That's right. And we will have to be extremely cautious.
Those on board must take control of every operation and not assume that someone has thought it all out correctly beforehand. The procedures set out in the manual will be the starting point, but circumstances may have changed and further precautions may be needed.
So let's first have a look at your tank cleaning plan.
The first stage is to identify the hazards, keeping as broad a view as possible. Ask, what if? What can go wrong? And what happens if the opposite to that intended occurs? For example, suppose someone has to enter a tank or cargo hold. What if the tank ventilation left some pockets of toxic gas or insufficient oxygen? What if someone fell? Secondly, assess the risks associated with those hazards. What would be the result? And how likely is it to happen? Inside the enclosed space, for instance, a fall or a pocket of toxic gas could prove fatal. Such incidents are not uncommon at sea. The experience of all those on board will be helpful in deciding how likely the hazards are. Then explore the options available to minimize the probability of these events occurring, and consider what could be done to reduce their impact. For hold or tank entry, has ventilation been adequate? Has the atmosphere been thoroughly tested? Is BA required or a backup team needed? Is training required? Then carry out a thorough cost-benefit analysis of all the options available. On that basis, implement the most appropriate option to manage the risk. Finally, and crucially, constantly monitor the outcome and check that the plans are effective, and modify them when necessary. In practice, risk management is a circular process, not a linear one.
A seafarer or ship manager, when he approaches a situation, must have a few questions in mind. What is different in the job activities today? Are there any new circumstances, new people involved? Any change in the environmental conditions? What are my concerns? If there is a system failure, is there any backup system available?
Morning, Chief.
Good morning,
How
sir.
are you this
I'm
morning?
fine.
Yeah. We'll talk about risk in the galley today.
Yes, sir.
Could you tell me what are the risks involved in galley?
The fire.
The fire is the first, yeah?
For most procedures, those on board will be able to employ the risk management approach themselves. Indeed, by undertaking the assessment, crew members will more readily understand the process and be better placed to introduce control measures.
Some of the problems that you have in this very big fleet of ships that you run.
For a wider view, however, or when introducing the process, many ships operators feel the need to bring in independent consultants.
The ships we run. Yeah. Now the difference here, of course, is that the owner not
The first step is a risk management audit, a review of the procedures and the systems to check what is already in place. The objective is not to catch people out, but rather to see what's going on and suggest improvements. How thoroughly are procedures being carried out by those on board? What further measures are needed to ensure safety? Are the ship's officers taking the widest possible view of the hazards and taking steps to manage them? One of the fundamental concepts of risk management is that you're in control of your own destiny. You need to check everything yourself, or ensure this responsibility has been delegated to someone else. Never assume everything is all right. Ask questions. Check how procedures are carried out.
Last night, I stopped the loading when I found out that the ship is heeling to the starboard side for more than 3 degrees.
Yep.
So I go to the foreman and I stop the operation.
Yep.
Because I have to make the ships in upright position, but it will take time. But they are insisting to load immediately. Right. But I told them no, I have to upright the ship for the safety of the vessel.
Yeah, excellent. So there were commercial pressures put on you. You resisted it in the interest of the safety of the ship. The problems that you have in case there was
A ship that is clean and well run will also be less likely to experience accident claims from shore-based personnel.
Yes.
car doors facing inwards.
Yes, facing forward.
Access into the container.
Yes.
Very difficult. This side the same. no bolt holes to take off so that you could put spray in or anything of that nature in this particular. But you're aware of those problems?
Yes, if there's something fire here, we cannot do anything because we cannot off any. So just to tackle some cooling or some fire.
Exactly.
Which give the average
The ship's
weather.
procedures will be effective. The manual will have been checked and
You
approved,
assessed it that way, fine.
but it cannot be perfect. It cannot cover all the circumstances for every moment on your ship.
Concerns about what happens if there's a fire.
Yes, well, this is always a concern, so that the people climbing on the containers for the height at sea.
If we can just come forward here a minute, look. I was thinking you could perhaps jump. Well, you can, in fact, can't you? You could get over here.
Yes, yes.
Run your fire hoses forward and certainly get onto this.
Get onto that
first
stack.
tier. But then if there's a big gap in your bays, you're stopped again from getting forward. Do you ever exercise your crews in fighting fires on the tops of the containers?
No, because of the risk at sea. If it's if it's an exercise, then we don't want to lose anybody over the side.
Fair enough.
Or off the top of containers.
Fair enough, that's all right.
It is still the responsibility of the senior management on board to get things right. You need to use your own expertise to work out procedures that take all the potential hazards into account.
Okay, we're planning a passage from Larnaca here in Cyprus to
Let's take an example.
in Italy.
This vessel is bound for Giao Tauro in southern Italy,
There's no
and this means passing through the Straits of Messina, a narrow channel with a great deal of traffic.
possible squally
Currents
weather.
can be a problem.
Which way are we going, please?
So first of all, I have to.
The ship could go round Sicily, but this is not commercially viable, adding 20 hours to the passage.
And also the.
There are operational procedures for close inshore waters, but they're just general rules. Are further precautions needed?
Before we approach the ferry areas.
Will this be a day or nighttime passage?
But, I think
The captain
the,
explains
ferries
to the
are
risk
very
assessor
busy.
what additional precautions he usually takes. These might include doubling the watch, having the engine room on standby, and checking all navigational equipment before arrival in the
Of course
Straits.
here, but the important point is here where the ferry boats run across. We have to be plotting all the ferries on ARPA.
What would your views be if you've got a fog warning in the Straits?
This is the kind of thoroughness that is at the root of risk management.
Okay, no, that's all right, you know.
The past experiences of the entire crew form a useful pool of knowledge in assessing the risk of any procedure.
So we go round a little bit.
Where a risk management policy has been introduced, what should seafarers do differently in their day-to-day tasks?
Do not blindly follow the pieces of paper that are pouring aboard the ship day after day and waiting for the next instruction before they take some action. They should learn to think for themselves and be proactive and learn to look at the situation as it develops and react accordingly.
In the light of risk management, we propose that people ask more questions. Just because a procedure has been followed that way for several years does not necessarily mean that it is safe and risk-free to continue. Collective experience will provide data on what could go wrong, the chance or probability of a loss, and the consequences if a casualty does occur. In my opinion, common sense would provide the starting point for most of the questioning.
This ship is preparing to go to dry dock. What are the navigational risks?
So now in the approaches to the port, the pilot is going to board about a mile off from the Raycon buoy. Before we come up to the pilot station, we would be dropping a draft to come up to the required docking draft, which would be a maximum of about 6.8 meters. And since the propeller immersion is going to be 8.86 meters, we have to remember that the propeller is not going to be fully immersed. So the chances that you could have a problem with your steering, right?
We have a very strong tidal stream out here in the river.
Okay.
So we'll make sure that we pass this passage at least during the slack water time, because it's a very strong tidal stream.
That would be excellent. And I see that you've already worked out your tides and you've got all your reporting points.
I've done that.
Worked out. Okay, that's excellent.
All the risks need to be identified and all the possible ways of reducing them examined. Everyone involved in the planning and implementation of each procedure should keep their eyes open and express their opinions. The personnel, environmental and commercial risks also need to be addressed. Indeed, if the commercial risks are not properly considered, serious financial penalties could result, which may well affect the livelihoods of the crew.
See the facts from you.
Right.
And we have already submitted it along with the specs.
Okay. Captain, what are the precautions you will be taking when blasting is going on?
One of the precautions that we've highlighted is that when the blasting is going on, we will not be doing the hydraulic repairs, and when the hydraulic repairs have to be done, we will ensure that the blasting is stopped.
Thorough risk assessment of all parts of every task is the only certain way to minimize accidents, improve safety, and maximize the commercial earning power of your ship.
Put in the designation of the person who will be looking after that job.
Detail and discuss every risk with your colleagues.
Don't forget.
Risk management is not just of concern to officers. Everyone on board needs to own the process, to be aware of the concepts, and to carry out each task having considered all aspects of the hazards involved. Remember to keep asking yourself, what if?
So, we have to eliminate any risk of fires by checking the atmosphere. Check for what? Check for hydrocarbon vapors. Should not be present. Check the other compartments. Don't forget, you work on board ship because heat travels by conduction. You have to think about it.
Trainees, we have prepared for you a welding exercise today.
You may have covered all the safety points and dealt with all the hazards in your own operation, but have you considered the wider possibilities? What's happening the other side of the bulkhead you're working on?
But we have to look also behind the bulkhead to see if there's no flammable materials or oil splashes. We have to remove all flammable materials to produce a safe and fire-free welding.
Risk management and new legislation, including the ISM code, are closely linked.
Always to take care, especially.
The ISM code forms the basis for a risk management system. Effective risk management is based on a clear understanding of the relationship between risk and planning. The ISM code provides that linkage.
What happens if somebody wants to go and put water on deck, starts the fire
That's
pump?
a problem. Actually, engineers know how they cannot start nothing. They don't give a power for nothing on the deck.
So.
Also, the bridge is advised always to each starting on the deck, for example, deck air compressor, for example, fire pump or something like that. They have first to inform engine room to engineer. Duty engineer will give a permission to start that or not.
So there is a risk at this particular point. You're aware of it. Everybody on board has been told about it. So this particular type of risk has been well managed.
Correct.
A key aspect of risk management is that it must be important to the heads of department. If risk management matters to the captain and chief engineer, it will become important to everyone on board. Little by little, a safety culture will develop in which everyone works to manage risk and so minimize the number of accidents and losses. An important part of that is a no-blame reporting system.
A no-blame reporting system is important in risk management to make sure that all incidents or near misses are reported. The seaman or the seafarer has to be in a position to report them freely and without the fear of losing his job.
Accidents do happen for a reason. Now, fixing blame on a person after the accident has happened will affect the investigative process in finding out the root cause of a problem and thereby developing a procedure or a process of eliminating it in future operations.
Everyone must realize that accidents can happen to them. No one is bulletproof. If the risks are assessed, they can be managed. Safety needs to become everyone's first priority. Make sure you understand the key points. Risk involves the probability and consequence of a hazard occurring. Risk assessment must be dynamic to reflect changing conditions. Never make assumptions. Always ask, what if? Risk management involves everyone on board. Read the study guide that accompanies this video and see the video again. Rather than dealing with each incident after it occurs, it's far better to examine the management process on your ship to see how to prevent accidents before they occur. It takes effort and vision to achieve a safety culture, but the rewards are worth the effort. The ship will become a safer, more efficient, and a happier place in which to work. Risk management as part of a cohesive safety culture is the only way to minimize accidents on board.